I'm actually going to share my screen and go to the camera. All right, let me move this off my side. There we go. All right, so we're going to be in 9.2. And that deals with inverse functions. So I'm going to go through a few definitions on them first, and then we'll get into the actual homework problems. So all functions, if one-to-one, have an inverse function. So the inverse of a function is such that if putting x into the function gives y, then the inverse when putting in y gives x. So what they mean, if I had a function and I put a value for x in, such as 2, and when I put 2 into that function, it gave me a y value of 5, then the inverse function, if I put the 5 into the equation, would give me the answer of the 2. So they undo each other in a way. So with ordered pairs, we simply switch the x and y values. Of each point. So if I had an ordered pair and it had a point 1, 5, then the inverse would be 5, 1. All right, so we got a formula that we use to find the inverse of a function. So to find the inverse of a function. So this is what we'll sort of be doing to our homework problems. So the first thing we do, we replace the f of x notation with a y. Because remember, f and x and y are the same things, basically. So we switch the f of x with a y. Second thing we're going to do, we're going to switch the x and the y. So if we had y equals 3x, we're going to switch them, and we'll have x equals 3y. So we just switch them around. We then solve for the new y. All right, so we go through, we solve it for the y, and then our last step is we're going to replace y with f inverse of x. So that little -1 that looks like an exponent is just symbolism, and that represents the inverse. So this would be inverse notation. So that when we're done, we'll have f -1 of x equals whatever that inverse equation is, okay? And then y'all, way up here when I was giving y'all this, it said all functions if 1 to 1. So we need to figure out how to tell if a function's 1 to 1. So to find out if it's 1 to 1, we use what we call the horizontal line test. So I did a vertical line across it to see if it was a function. Now I'm going to run a horizontal line down it to see if it's 1 to 1. If it's 1 to 1, then it will have an inverse equation. All right, so horizontal line says if it is possible for a horizontal line to cross a graph more than once, then the graph is not 1 to 1. Okay, so it can only hit my graph one time to be 1 to 1. So let me draw something here. All right, so I'm just going to draw a little graph that sort of comes up, goes through the middle, and then goes up. So if I was to run my horizontal line down this, it only hits my graph once everywhere I go, which means, yes, this graph would definitely be 1 to 1. Now, y'all, I'm going to draw another one real quick. So say I had a graph that went like that. You would still what? Come down with that horizontal line. And notice it don't cross the graph more than once. So this would also be a yes. All right, so I'm going to turn my page over here. Y'all got this?
Wait.
All right, so let me draw one more of these. So this time I'm going to have a graph come up, sort of turn, and just come back down, almost like a parabola. So now notice on this one, if I run my horizontal line down it, I'm hitting it on the left side and the right side of my graph. So this would definitely be a no. Now, I'll tell you what they can do, though. They can restrict the domains on these so that only the part is shown, and they can make them 1 to 1. But if they're using the whole domain on this, then this would definitely be a no. All right, so I'm going to go through and show you sort of what these homework problems are going to look like. So this one wants me to find the inverse of the relation. So what they're doing, they're giving me ordered pairs. I have 0, 5, 6, negative 6, negative 2, 9, and then finally 5, negative 5. So they're giving us a set of ordered pairs. So remember, we said earlier that if you had ordered pairs, all we have to do is switch the x and y's around. So I'm just going to come into each pair of these points and switch them around. So that on my answer, we'll get 5, 0 for the first point. This one will give me what? A negative 6, 6. This one will give me a 9, -2. And then finally, y'all, I get a -5, 5. So in the ordered pairs, all we're doing is just switching them around. And we're going to be done, okay? All right, so this one says find an equation of the inverse equation. So they're giving us x cubed times y equals -8. So in this form, since they're giving me x's and y's in this equation, all we got to do is switch the x and the y around so that the inverse would be a y cubed x equals -8. Now notice, I don't switch the signs on the numbers. All I did was switch that x and the y around, just like we did in these points. All right, next, use the horizontal line test to determine if 1-to-1. All right, so let me draw this little graph here. So here's my x and my y. And this first graph is just slowly going to go uphill, and then it curves up. All right, so on this graph, I would just come down with my ruler, run my horizontal line, and notice I don't touch the graph more than once anywhere on that line, so this is definitely a yes. So y'all, there'll be about 3 or 4 with little pictures. That's all you're going to do. Just run your little horizontal line down that. See if it crosses it more than once, okay? All right, for the following. A, we're going to determine if 1-to-1. And then B, if it is 1-to-1, then find the inverse. So this is the kind of question that we like to put on our final exam, okay? So the first one they're giving me is f of x equals x minus 9. Now, the easiest way to do these graphs and check them if they're 1-to-1 is just to plot them on your calculator. So what I'm going to do is I'm going to go to my y equals and clear this out and put in the x minus 9. So here we go. We got x minus 9. And we just want to look at the graph. So I'm going to hit graph. So it looks like a straight line. But if I run my horizontal line down that graph, it does not cross it more than once. So this is yes, 1-to-1. So since it's 1-to-1, we got to find the inverse equation. So this is what goes through that little formula I gave you. So the first thing it said was replace f of x with a y. So this is going to be y equals x minus 9. So I replaced f of x with my y. Then it told me to switch the x and the y around. So this will give me x equals y minus 9. So I switched the x and the y. Now what you want to do is solve that for the y. So since my y is right here on the right side and it's got 9 being subtracted, I'm going to add 9 to both sides. So that here I get x plus 9, can't do nothing with that. Over here, the negative 9 cancel, and I'm left with my y. So basically I got y equals x plus 9. All I did was just switch the sides. So here all we did was what? Solve for y. And then remember, my last step is to replace the y with the f inverse notation. So that f inverse of x equals x plus 9. Now, y'all, the math lab gives you this part. All you'll do is put in that right part. All right, and that's it. Any questions on that?
Nope.
All right, y'all. So our next one says f of x is going to equal 6x minus 2. And you'll sort of see little patterns on these. Like if one function was being subtracted, its inverse is probably going to be added. So this one's got something being subtracted and multiplied. So the inverse will probably have stuff being added and divided. So it's almost like counter moves on these. All right, so let me see if it's 1 to 1. I'm going to go y equals and clear that out. And then put in a 6x minus 2. So let's hit graph, and that should be another straight line. And then I would just run my little horizontal line down it, and notice it does not intersect it more than once. So this is definitely, yes, 1 to 1. All right, so since it's 1 to 1, we're going to find the inverse equation just like we did above. Replace the f of x with a y. So this will be y equals 6x minus 2. Switch the x and the y around so that you get x equals 6y minus 2. So here, let me just draw an arrow. All I did was switch them around. All right, so now you got to solve this and for the y. So I'm going to get the 6y by itself. So I'm going to add a 2 to both sides. So notice what I get on this side, I'll get an x plus 2. And then that's going to equal my 6y. All right, so I'm going to bring that up here. All right, so now the 6y needs to be a 1y, so I'm going to divide both sides by 6. So that the 6's on the right side cancel, and I get my y. All right, we cannot do anything to this because this one x only has a 1 in front of it, and the only way to reduce numbers, you would have to do it to all 3 parts of that. So since I cannot reduce it, I'm going to leave it at x plus 2 over 6. All right, I'm going to switch this around and get an x plus 2 over 6. And then y'all finally replace the y with the f inverse of x notation. So in MATLAB, what you'll put is your x plus 2 over 6. So they're not too bad. We got a few coming up that are a little bit trickier. I'll give y'all a second to write that. Alrighty, so y'all, this next one has f of x is going to equal 6 over x plus 9. All right, so I'm going to graph that. Let me clear that. So since I'm doing a fraction, when I put it in the calculator, I'm going to put parentheses around the bottom of my fraction so that I get 6 divided by parentheses x plus 9, close parentheses. Now, let me show you the other way you could have done this without the parentheses. So I'm going to clear that. Remember, I can hit alpha y equals, and it'll pull up that box, and I hit enter on ND. It'll make my, what I'm putting in actually look like a fraction. And then I can put in the x plus 9 like that. So either way, it'll work. So what we want to do is hit graph. Alrighty, so we got part down here. It's not going to hit more than once, and I'm following this curvy part. And it.
Wait,
Yes, ma'am.
Every time I hit my graph, I don't get the same result.
You don't get what I'm getting? So do this. On your calculator, hit that zoom button in the middle, and then hit number 6 for zoom standard.
Wait, zoom and 6. Oh, okay, I got it. Thank you.
Is it pulling it in? All right. So that's definitely going to be yes, 1-to-1. And y'all, I'll tell y'all a little trick. All the ones you're doing on homework are going to be 1-to-1. So you're going to have to find the inverses on all of them. All right. Since this is 1-to-1, I'm going to replace the f of x with a y. So I'm going to have y equals 6 divided by x plus 9. Then it told me to switch the x and the y around. So I'm going to switch them two around so that I get x equals 6 divided by y plus 9. Alrighty, so several ways to solve this. So one way I do it is I treat the x like it's got a 1 on the bottom, and I sort of do cross multiplying. Cross multiplying takes the top of one fraction times the bottom of another fraction. So this x would multiply by the y plus 9. That's going to equal the other top times that bottom, which will be the 6 times the 1. All right, so this is basically x times y plus 9 equals 6. So what you got to think about on this one is we're solving this for the y plus 9. So what I want to do is move this x. I don't want to multiply that. I'm going to come on both sides and divide by that x. Because what will happen is these x's will cancel, and that'll give me a y plus 9 on that side. Over here, we cannot do nothing, so that'll just stay 6 divided by x. Now, we got to get to y by itself, so since the 9's being added, we need to come on both sides and subtract 9. So that after subtracting 9, these 9's cancel, and I got my y like I wanted. Over here, we got 6 divided by x minus 9. We cannot do nothing to that. So that'll just be 6 over x minus the 9. And then remember, my last step, replace the y with f inverse of x. So you get 6 over x minus 9. Now, y'all, I'm going to show y'all another way that you could have solved this starting at this point right here. So this will be the other way y'all might have learned it. So the other way, they would have multiplied both sides by y plus 9 times that x equals y plus 9 times this side. Because what happened over here, they cancel. All you have is your 6. And then what they would have done was distribute this side so that you get a y times x is a yx plus 9 times x is a 9x. All right, so here we go. We would have wanted to get the yx by itself, so we will subtract 9x. So I get a yx. Over here, you can't do nothing, so that's going to be 6 minus 9x. And then your final step would be to divide by the x to get the y by itself. And then you'd come in and divided everybody by x. So notice what happens. That cancels and you still get a y. Can't do nothing with that. That's going to stay 6 over x. But right here, those x's will cancel and give me my minus 9. So no matter which way you solved it, you'll get the same answers on those, okay? And then that's what MathLab wanted right there. All right, let's throw some cubes at you. F of x will equal x cubed minus 6. All right, so let me go to my y equals. I'm going to clear that. X to the third, I got x. Use that arrow up key over here. Put in your 3, and then arrow right. Now, if you got the old calculators, it'll give you that. You'll put your 3 in and then close those parentheses on the old one. And then put in your minus 6. So we hit graph. And once again, if I run a horizontal line down that, it's only going to intersect it once everywhere. So that is definitely yes, 1 to 1. All right, so let's find the inverse equation. We're going to replace the f of x with a y. So I get y equals x to the third minus 6. I'm now going to switch that x and the y around so that I get x equals y to the third minus 6. All right, so we're solving it for the y, so we need to get this y to the third by itself. So I'm going to come in and add 6 to both sides so that I get a x plus 6 equals my y to the third. So to undo exponents, we take roots of stuff. Since this has an exponent of 3, you want to come to both sides and take a cube root. So I'm going to take a cube root of y to the third. The root has to match the exponents, because what happens if this root matches this exponent, they cancel each other out, and all that's left is my y. And then on this side, since we don't know the value of x, we're not able to go no further. So that's going to stay a cube root x plus 6. All right, so I'm just going to switch it around and get y equals the cube root x plus 6. So this should be bringing back memories when you got these exponents. If that was a y squared, I'd have took a square root. Y3s, I take cube roots. A y4, I would have took a fourth root, and so on, okay? All right, then what was my last step? Replace the y with f inverse of x equals the cube root x plus 6. All righty, so if you got exponents in one equation, you'll have these radicals in the inverse equation. All right, let's see. Next, they're giving me f of x equals 7x squared plus 2. Now, y'all watch this. They're telling me x has to be greater than or equal to 0. So let me show you how you would graph that. Because if you graph this whole thing without messing with the domain like they got, it won't be 1-to-1. But they're telling us x has to be greater than 0. So first, let's go to y equals and clear that. And let's put in the 7x squared plus 2. So I got 7x squared plus 2. Now, anytime they tell us the x has to be greater than or equal to 0, we need to adjust the window. So I'm going to hit the window button. And you see where it says x minimum is -10? We want x minimum to equal 0. So let's put a 0 right there. And then enter. So now we got x greater than 0. We can go to our graph and hit graph. And notice what it did. It didn't put all these negative x's on it. It started at the 0 on the x-axis so that when we come down with our horizontal line, we do not cross it more than once. So that this is a yes 1-to-1. So let me go back and do a standard. If you didn't fix your x's, see, it would have gave you the whole graph. And if it gave you the whole graph, it wouldn't have been 1-to-1. So that's why they're restricting our domain, okay? So window, x minimum 0, and then graph. All right, so since this is 1-to-1, we need to find the inverse. So replace the f of x with a y. Switch the x and the y around. And then we're going to solve this for the y. So first, I'd like to get the 7y squared by itself. So I'm going to come in and subtract 2 from both sides. So I get x minus 2 equals 7y squared. All right. Before I mess with that y squared, I need to divide both sides by 7. So x minus 2 divided by 7 equals 7y squared divided by 7. So you cannot do nothing on the left side, which all the right sides are 7's cancel, and all that's left is the y squared. So since I got a y squared, I'm going to do the same thing I did up here, except I'm going to take a square root of both sides. And y'all, that left side, everything has to be under that square root. All right, so we cannot do nothing to the left side. The right side, that exponent 2 cancels with the 2 that's on the square root. Remember, if there's not a number here, it's automatically a 2. So those cancel, giving you the y. This side will stay the same, x minus 2 over 7. So my final step would be what? F inverse of x equals the square root x minus 2 all over 7. Now think on this one, they give you most of the answer and you just had to fill in part of it. All right, so let me give y'all a second on that. All right. All right, so one more of these and then we'll get into our 3.5 stuff. This one has f of x equals the square root x plus 6. So now we're going the other way. Earlier we had 2 with exponents. We did square root stuff to them. So first of all, let me see if this is going to be 1-to-1. So I'm going to put my window back on standard. And then I'm going to go to y equals. Clear that. So first I need the radical. So that's going to be second x squared on the side. It'll bring up your radical. And then you put in the x plus 6. Once again, old ones have the parentheses. So put your x plus 6 and then close your parentheses. All right, so no restrictions on my domain, so I can hit graph. And once again, that one's a slow climber, but it does not intersect it more than once. So that would be a yes, 1-to-1. So what we're going to do, replace f of x with a y. So we get y equals the square root x plus 6. Switch the x and the y so that we get x equals the square root y plus 6. Now I got to solve that for the y. But y'all, that y is under that radical. So the first thing you got to do is get rid of that radical. Now remember, that radical really has a 2 in the notch. So to undo a square root, we square both sides. So I'm going to square the x, and then I'm going to square the radical y plus 6. So what's happening, this is x times x, which will give me x squared. Over here, this exponent cancels that radical, and all that's left is the y plus 6. So remember, exponents cancel radicals, radicals cancel exponents. All right, y'all, the last move, get that y by itself would be to come in and subtract 6 from both sides so that I get a x squared minus 6 equals my y. So I'm just going to rewrite it with the y on the left side. And then finally replace the y with my f inverse. And that's going to equal x squared minus 6. And then that's what our math lab wants right there. All right, y'all, so that was 9.2, and the main thing was just remember to replace the f of x with the y, switch them, solve it for the new y, and then when you're done, use your f inverse equations, okay? All right, so let me get us a little start on 3.5, and then I'll do a break about 1 for y'all. This is systems of equations. And we're going to deal with 3 variables, but first I'm going to work some of these with 2 variables. So I'm going to bring back memories. So I'm going to solve by the elimination method. All right, so our system is going to be 9x plus 8y equals 55. 3x minus 8y equals negative 67. So that's the system they're giving me. So to solve by the elimination method, they want us to add these together and be able to get rid of one of my variables. Well, right off the bat, you notice I'm going to eliminate the y because I got an 8y and a negative 8y. If I add those together, those will cancel. So let's add these together and see what we get. So 9x's plus 3x's will give us 12x. Notice the 8y and the negative 8y cancel. On the right side, let's see, we got what, 55 plus a negative 67. That's going to give us a negative 12. Now we've got a single variable in a single equation. We're going to solve this for the x. So 12x equals negative 12. To solve that, I would divide both sides by 12. So 12 divided by 12 gives me a 1x. Here I got a negative 12 divided by 12. That gives me a negative 1. So now we know x is negative 1. So what we're going to do now is back substitute x is negative 1 into one of the original equations and solve for y. Okay, because I know what the x is, I can go pick either one of these equations. So I'm just going to pick that first one. I got 9 times x plus 8 times y is going to equal 55. I know what x is. It equaled negative 1. So notice I've only got one variable, which is the y. So let's solve this. I would multiply that first and make that a negative 9 plus 8y equals 55. All right, so let's solve this. We would add 9 to both sides. So I get my 8y. And then let's see, 55 and 9 is what, 64. And then finally divide both sides by the 8. So that y equals 64 divided by 8 is 8. So we know the y, we know the x. So our answers have to be in ordered pairs. And you got to put them in order, your x and then your y. So my x was negative 1, and then my y was 8. Okay, so when you got 2 variables, they go in order. When you got 3, we'll have what we call an ordered triple, and that'll have an x, a y, and a z. All right, so y'all, we're going to go to the next one. So if you got variables that are the same numbers but opposite in sign, that's the first one I would eliminate, okay? All right, 5x plus 4y equals negative 13. 4x minus 1y equals -2. So, if you notice, I cannot add a 5x and a 4x and get rid of them. I cannot add a 4y and a -1y and get rid of them. So what I'm going to do, we have to change one of these equations. Now, y'all hang on 1 second. Yeah. Okay, hang on just a second. Y'all, I got an emergency. Let's take our break. So we'll take a 10-minute break and then we'll get back on this, okay? So I want to stop and work this problem. Now, after I do this problem, I'm going to show y'all how to do these on the calculator, okay? So what happened on this, and I didn't have anything that I could add and get rid of. So what I got to do is change some rows here so that I can get things to cancel. So if you notice, I'm going to try to get rid of the y's here because I got a 4y here. If I can make a -4y here, when I add them, they'll cancel. So what we're going to do is we're going to change row 2 by multiplying by 4. So if I multiply -1y by 4, that'll make that a -4y. So we're going to take that whole row and multiply by a 4. So that'll give me 4 times 4 gives me 16x. 4 times -y is a -4y. And then -2 times 4 is a -8. So you multiply the whole equation by 4. So now what I'll do is I'll bring down my 5x plus 4y equals -13. Then I'll put the 16x minus 4y equals -8. So I changed the second row into the 16x minus 4y equals -8. Now I can add these and get rid of the y. So 5x, whoop, that was a 16x there. So 5x and 16x give you 21x. The 4y, -4y cancel. And 21x is going to equal -13 and -8, which is a -21. Now to solve that for the x, we'll divide both sides by 21. So that x equals -1. So now that I know x is -1, I can find one of these equations and plug it into. So I'm just going to pick that first one again. So I got 5 times x plus 4y equals -13. My x was -1. All right, so here we go. 5 times -1 is -5 plus 4y equals -13. I need to get the 4y by itself, so I'm going to add 5 to both sides. So that the 4y is going to equal -13 plus 5. Oh, that's what, a -8. And then finally, divide both sides by 4. So that y is, looks like what, a -2. So remember, your answer for that would be a -1, comma, -2. So let me show y'all how to do this on the calculator. On the calculator, let me clear. On the left side where you got that x -1 button, right above it, it says matrix. So I want to use the matrix by hitting second and then the x -1. So second x negative 1 brings out the matrix. So the first thing we're going to do is edit. So go to edit and hit enter. So a matrix, we got to put in how many rows by columns. So this equation I just did had 2 rows. So that's going to be 2 rows times, I had the x's, the y's, and the numbers. So it had 3 columns. So we go 2 rows, enter, 3 columns, enter. So what that does is that makes 6 places for me to put my 6 numbers. We do not put letters, only the numbers. So I got a 5, enter, 4, enter, negative 13, enter. That takes my first equation, the 5x plus 4y equal negative 13. Second row would be a 4, enter, negative 1, because that was a negative y, and then a negative 2, enter. So I put all these numbers in. Now I'm going to quit that screen by hitting second mode. So we have this system of equations in that matrix now, and that was my matrix A. So to solve it, we hit second x negative 1. We go to math, so you arrow over to math. From math, you're going to arrow down and find RREF. So arrow down to RREF, hit enter. Now go get that matrix by hitting second x negative 1. Notice it says matrix A, that's my 2 by 3. So I hit enter. And y'all to get this answer, remember I got what, a negative 1, negative 2. Here you go. The first row is your x, which is negative 2. The second row is your y, which is negative 2. So 1x was negative 1, 1y was negative 2, which are the same answers we got. So I'll get y'all good on using that calculator on some of these, okay? And I think I'll send a video doing that on the calculator also. All right, so I'm going to do a tricky one here. I got 4x minus 9y equals 10.5. Then I got 7y minus 2x equals a negative 6.5. Now, the first thing I noticed on this, they're out of order. You got to have all the x's in the first column, all the y's in the second column, and then all the numbers. So this one needs to be rearranged. So the top row will be 4x minus 9y equals 10.5. Then I get a negative 2x plus a 7y will equal a negative 6.5. So that row had to be rearranged so that all the x's are in the first column and then the y's. Now, at this point, you could put it into the calculator under that matrix, and I'll show you all that after I work this. All right, so I'm noticing nothing will cancel if I add, and it looks like the easiest thing to do, since that's a 4x, is to make this into a negative 4x somehow. So to make that a negative 4x, I got to multiply row 2 by 2, because 2 times negative 2 would make that a negative 4. So I'm just going to multiply my second row real quick. So 2 times negative 2 will make that a negative 4x. 2 times 7 will make that a 14y. And then 2 times negative 6.5, what's that, negative 13? So this will be my new row 2. So bring down row 1, which was 4x minus 9y equals 10.5. The new row 2 was a negative 4x plus 14y equaled negative 13. Okay, so now we get the x's to cancel. Negative 9y plus 14y gave me 5y. And then let's see, negative 13 plus 10.5 is going to give me a negative 2.5. All right, so now down to one variable, solve for the y. So we'll divide both sides by 5. So that cancels, give me 1y, and then a negative 2.5 divided by 5 gives me a negative 0.5. So remember, we know what the y value is, so now we got to plug it in here and get the x value. So I'll just go back to that first equation again. 4 times x minus 9 times my y is going to equal 10.5. So I'm just back substituting. All right, so let's put in a negative 0.5. So the first thing I'm going to do is multiply these two negatives. So negative 9 times negative 0.5 is going to equal a positive 4.5 equal to 10.5. All right, so now let's subtract 4.5 from both sides. So my 4x, 4.5's cancel. 10.5 minus 4.5 is going to give me 6. And then y'all divide by 4 and be done. So x equals 6 divided by 4 is going to give me 1.5. Now, since this one gave me decimals, I'm going to leave the answers as a decimal and not turn them into fractions. So that this gave me a 1.5 for the x and then a negative 0.5 for the y. All right, so watch this. Let's do this on the matrix. Second, x negative 1. I'm going to hit enter. Second, x negative 1. I'm going to go to edit, hit enter. So I've still got a 2 by 3, so I'm going to hit enter, enter, and then I'm going to change my numbers. So I had a 4 enter, negative 9 enter, 10.5 enter. Next row I had a negative 2. Remember, you got to do it when the switched rows, not the original. You got to have the x's and then the y's and then the number. All right, then I had what, a 14. No, that was a 7y, so hit enter. And then a negative 6.5. All right, so I got it in there. Remember, I quit the screen. And then I go back to do the math on it. So I hit second, x negative 1, go to math, arrow down to RREF, enter, and then go back and grab the matrix by hitting second, x negative 1. I'm still using A. All right, so remember, I should get what, a 1.5 and a...
Wait, how do you quit the screen after?
Oh, I hit the second button, and then the one right by it that says mode. I just hit the blue button and then the mode, and it'll quit it for you.
Okay, thank you.
Well, and y'all look at that. That's sweet, ain't it? First row, 1x is 1.5. And in the second row, since the one's in the y column, 1y equals negative 0.5, which is exactly what we got. So
Wait,
I love using that calculator, if nothing else, to sort of check myself.
After you hit out of it, where do you find the...
So let me get to that point. So So say I got to this point and I'm going to quit my screen. So I'll hit second mode and quit my screen. Now we got to go get the RREF. So hit second, x negative 1, back to the matrix. Arrow over 1 to math. And then scroll down and find that RREF. It's like number 10. It's got a B by mine. So it must be like the 12th thing in the list. Go to RREF and hit enter. And then that'll bring that RREF to your screen. And then now you go back and get that matrix. Second, x negative 1. So if you notice, I use that second x negative 1 probably 3 or 4 times on each problem. But we're using A for our matrix, so you just hit enter. And it should be bringing up RREF and then matrix A. And then you'll hit enter on that, and it'll give you those answers. So let me test y'all on the calculator on one. Let me give you one to do on the calculator. See what y'all do, and then I'll knock it out for you. So we'll do this one on the calculator. 5x plus 2y equals 36. And then 2x plus 5y is going to equal 48. So first thing y'all want to do is hit second x negative 1. And then we're going to arrow over to edit so we can put in our matrix and hit enter. So we still got 2 rows. So 2 enter and then 3 columns. And you'll notice it puts 6 little spots down here in the same order we need them. Now put in the numbers. 5 enter, 2 enter, 36 enter, and then 2 enter, 5 enter, and then 48 enter. So now we've got our matrix in there. We quit the screen by hitting second mode. All right, so now we want to go in it and do the RREF to it. So we got to go grab the RREF first. So second, x negative 1, arrow to math, and then go down and find the RREF. Enter, and go back and now grab the matrix by hitting second, x negative 1. And we can enter because I've been putting all mine in the first one that pops up, A. So hit enter. Now for my answers, when I hit enter, it looks like my x is 4 for the first line, and then my y looks like 8 on the second line. Anyone want to do this one by hand?
I can try.
Say again?
I can try doing by hand.
Yeah, because this one's interesting to do by hand. Now I know what I'm going to get, a 4 and an 8 eventually. So notice, there's no numbers that are easy to pick on this one. Because I got 5s and 2s on both of these. So there's nothing I can do to this 2 to make it into a 5. So what I got to do is change both rows. Change both rows in order to get rid of one of these numbers. So I think what I'll do, the first row, let's see, I got 5s and 2s. So I'm going to multiply the first row by a -2. That'll make that a -10. And I'll multiply the second row by a 5, and that'll make that a +10. So I'm going to change row 1 and change row 2. So row 1, I'm going to multiply by -2. So -2 times my 5x plus 2y equals 36. So let's see what that'll give us. -2 times 5 is -10x. -2 times 2 is -4y. -2 times 36 is a -72. Now the second row, I'm going to multiply by a +5. So here we go. 5 times 2 gives me 10x. So now my x's will definitely cancel. 5 times 5 is 25y. And then, 5 times 48. What's that? 240. All right, so these are my two rows. I'm going to add them together now. And this is really the worst I can do to you on one of these problems is make it where you got to replace both of them rows. All right, y'all, here we go. The x's cancel. 25 and -4 give me 21y. And then 240 minus 72 is going to give us 168. All right, divide both sides by 21. And my y is 8. But we knew that because a while ago when we put it on a calculator, we got an 8. So now that I know y is 8, I'm going to back substitute. So I'm just going to use that first equation. 5 times x plus 2 times y is going to equal 36. And I know that that y is an 8. So I'm going to multiply that. I get 5x plus 16 equals 36. All right, so solve that. I'd probably subtract my 16. So notice I get 5x equals 20. And then y'all final step, divide by 5. And let's see, x is 4, which is what we got earlier. So then I still get what, a 4, 8. Okay, so not too bad. You like it when you start out and you got numbers that'll cancel. But if not, you might have to change one row or even two rows to get that to change. All right, y'all, those were two variables. What if I had like a 3x plus 2y minus 4z equals 16? This is an example of a equation in 3 variables. So the next equation I'm going to do is going to be a system of 3 variables. When you got 3 variables, you need 3 equations. So 3 variables, we need 3 equations. Okay, so let me write one up and show you what we'll do to this. All right, y'all. X plus y plus z is going to equal -4. 2x plus 4y plus 2z is going to equal 2. -x plus 7y minus 3z equals 56. So here's what we got to do. We've got to add 2 of these at a time and get one of these variables and eliminate it. Then I got to come back and use the other row with one of these other 2 and eliminate the same variable. So that what's going to happen a 3 by 4 equation is going to turn into a 2 by 3 equation like we just did. So let me work this one and show you what I would do to this, and then we'll have something to play with. So if I was going to do this one, I would probably start out and try to eliminate the x's. Because notice, negative x and x, those two will cancel the x. And then I got to come in and use the 2x with one of these other rows and eliminate the same variable, which means I'll probably have to change one of the rows. So we've got to do this twice to get rid of the x's. So first, I'm going to add, and let me call this row 1, row 2, and row 3. I'm going to add row 1 and row 3 because they're really quick. X plus y plus z equals -4. Negative x plus 7y minus 3z equals 56. So those two can be added without any changing because the x's cancel. 1y and 7y will give you 8y. 1z minus 3z is a -2z. And then 56 and -4 is 52. I'm going to call this row 4 now. So I used 1 and 3, got rid of the x's. Now we got to use row 2 in one of the other rows to get rid of the same x's. So what I'm going to do, because 2x and -x won't cancel, I'm going to multiply row 3 by a 2 so that I can make that a -2x. So I'm going to multiply row 3 by 2 and then add to row 2. Let me use my Roman numerals. All right, so row 3 was a -x, so we're going to multiply by 2. So 2 times a -x plus 7y minus 3z equals 56. So let's see what that'll give me. That'll give me a -2x. 2 times 7 is 14y. 2 times -3 is -6z. 2 times 56 is 112. That new row, we're going to add to row 2, which is a 2x plus 4y plus 2z equals 2. So notice what will happen. The x's cancel. 14 and 4 give you 18y. -6 plus 2 give you -4z. And then 112 and 2 give you 114. That'll be equation 5. So now we put equation 4 and 5 together. So we got our equation 4 and 5 sitting over here. But notice, they now make a 2 by 3 equation. Sort of like we was doing, that's why we did the 2 by 3s first, because to do these 3 by 4s, you got to turn them into a 2 by 3. All righty, so nothing looks easy to get rid of, but I got a -2 here and a -4 here. I'm going to multiply this row by a -2 because a -2 times -2 will make that a +4. And then that 4 will cancel with that -4, okay? So I'm going to change row 4 and add to row 5. All right, so we said multiply row 4 by 2. So 2 times 8 will give me a 16y. 2 times negative 2 is a negative 4z. 2 times 52 is 104. That's my new row 4. And then bring down row 5, which is oh, hold on, y'all. That was a negative 2 we multiplied by. My bad. So negative 2 times 8 is a negative 16. Negative 2 times negative 2 is a positive. And then negative 2 times 52 would be a negative 104. I didn't see my little negative there. All right, so that row was negative 16y plus 4z equals negative 104. We're going to add that to an 8y minus 4z equals 114. All right, so let's see what we get. Negative 16 and 8 give you negative 8y. The z's cancel. 114 minus 104. What's that going to leave me? 10.
Wait, I thought that was supposed to be an 18.
Oh, somewhere I got offline, didn't I? Let me find it. Which one?
The second row. It's 18.
Oh, that's 18y. Okay. So that's going to make this a 2y equals positive 10. Well, I was getting scared there for a second because I was like, hold on, one of my numbers ain't coming out right because I shouldn't end up with fractions on these. So y'all make sure you write your numbers down. That was definitely an 18 there. So now divide by 2, and we know y equals 5. So what you got to do now is take this y equals 5 and back substitute it into row 4 or row 5. Okay, so I'm going to pick row 4, which was an 8y minus 2z equals 52. Now I know my y was 5. So that gives me 40 minus 2z equals 52. To solve that, I'm going to subtract 40. So negative 2z will be, what's that, 12? All right, I'm bringing it up. Negative 2z equals 12. Divide by negative 2. And z is now a negative 6. So I know y is 5, z is negative 6. I take both them numbers and plug it back into one of the original 3 equations. Because now that I got 3 variables and I know 2 of them, I can get to the last one. So I got an x, which I don't know, plus a y, which I did know. Where was y? 5. Plus my z, which I know, which is a negative 6. All that's got to equal negative 4. All right, y'all, so 5 and negative 6 will give you negative 1. And then final step will be add 1 to both sides so that x is a negative 3. Now, since I had 3 parts of this, this will be an ordered triple. X first, which was negative 3, y, which was 5, and then my z, which was a negative 6. So those are fun, right? So now we're going to do this on the calculator, and y'all know right where I'm heading, right? I'm going to go to the matrix. So to put this on the matrix, I'm going to hit second, x negative 1, and go to edit and hit enter. So now we have 1, 2, 3 rows. So that'll be 3 enter, and then 1, 2, 3, 4 columns. So this is a 3 by 4. Now notice when I hit enter, it gives me all my spots. So now let's put in our numbers. So X is 1 inner, Y is 1 inner, Z is 1 inner, -4 inner. Then I got 2, 4 inner, 2 inner, 2 inner. Then the last row, I got a -X, which is a -1 inner, 7, -3 inner, 56 inner. So remember, I got my matrix in. I'm going to quit the screen by hitting second mode. All right, let me clear that. I want RREF, so I hit second, X -1, and go to math, and then arrow down RREF. Hit enter, and then y'all go get the matrix, second, X -1. So since A is my 3x4, I'm going to hit enter. And then finally, I'm going to hit enter. So this should show 3 rows of answers. So since that's in the X row, you get -3 like we got. This one is in the Y column and it equals 5. And then this one's in the Z column and it equals -6. So that right column will always be the answers you're going to get on these, okay? All right, y'all, so next problem. How about 5x minus a y plus a z is going to equal -13. 3x plus 2y minus 3z is going to equal -16. And then x minus 3y plus 2z is going to equal 0. All right, so I'm going to do this by hand, but you could knock it out on that matrix really quick. So, I got to figure out what letter to get rid of. So, none of them look really easy. So, any of y'all want to pick a letter? I can do the X's, the Y's, or the Z's.
Top and bottom by -3.
Oh, and that would do the Y's then, right? So we're going to eliminate the Y's. Yeah, y'all could have picked anyone. So what we'll do then to do what you're saying, I'm going to take that top row, multiply by -3. That'll make that positive so that when I add to this one, it gets rid of the Y's, okay? So I'm going to call this row 1, 2, and 3. So multiply row 1 by -3 and add to row 3. All right, so -3 times the 5x minus the y plus the z equals -13. So let's see what that'll do. That'll give me a -15x. Negative times negative makes that a positive 3y. Negative times positive is a -3z. And then negative times negative is a positive 39. Add that to row 3, which was a x minus 3y plus 2z equals 0. So let's see, we had -15x plus x is a -14x. The y's canceled. -3 plus 2 is a -1z. And then 39 and 0 is 39. So we're going to call that row 4 now. So now row 5, we have to eliminate the y's, but this time we got to use row 2. So look at this. Since row 2 is a positive 2, I'm going to multiply row 1 by 2 to make that a negative 2y, and they'll cancel. So on this one, I'm going to multiply row 1 by 2 and add to row 2. Okay, so that'll be 2 times row 1, which is 5x minus a y plus a z equals negative 13. So let's see what we get. We get a 10x minus 2y plus 2z equals a negative 26. Bring in row 2, which was a 3x plus 2y minus 3z equal negative 16. All right, we'll add these, and that'll be my row 5. So let's see, 10 and 3 is 13x. The y's canceled. 2 and negative 3 is a negative 1z. And then negative 26 and negative 16 is a negative 42. That'll be row 5. So now we put row 4 and 5 together. So that would be row 4 and row 5. Now they make a 2 by 3. Y'all, it sure looks easy to get rid of the z's. So what I'm going to do is multiply row 4 by negative 1. So multiply row 4 by negative 1 and add to row 5. So negative 1 times negative 14x minus a z equals 39. All we're doing is changing all the signs. So I get a 14x plus a z equals a negative 39. Add that to the 13x minus z equals negative 42. All right, let me follow, make sure I did what I needed. All right, so now add these and get rid of the z's. So that's going to give me what? 27x equals negative 39 plus negative 42. Turn it on. So negative 81. And y'all, you got 27x equals negative 81. Divide both sides by 27. And I get x equals a negative 3. All right, so now that I know x is negative 3, I'm going to plug that into one of these two equations here. So let me get my paper here. So I had, let me write the two equations. All right, so x was negative 3. I'm going to just take that top one again. So I got negative 14 times my x minus z has to equal 39. And I said x was a negative 3. So let me multiply that first. So I get 42 minus z equals 39. I'm going to subtract 42 from both sides. So I get my negative z. And let's see, negative 42 and 39 is a negative 3. And remember, I can't leave the z negative, so I'm going to divide them both by negative 1 so that z equals a positive 3. All right, so x is -3, z is +3. What I'm going to do now is go back into my original equation, plug those in, and get my final answer. So 5 times my x minus my y plus my z, which is 3, is going to equal -13. And then this x was what? -3 also. All right, let's see what I got. I got -15 minus a y plus 3 equals -13. I'm going to add these like terms. -15 plus 3 is a -12 minus y equals -13. All right, let's go. Add 12 to both sides. -y, let's see, -13 and 12 is a -1. And y'all, same thing, can't leave the y negative, so divide everybody by -1. And it looks like I get y is a +1. So my triples would be -3 for the x, 1 for the y, and then what I get, a 3 for the z. Okay? So let me go back. Let's knock that out on the calculator. So calculator will be second matrix, go to edit, enter. We got a 3 by 4. And then let's see. My numbers were 5, enter, -1, enter, 1, enter, -13. Then the second row was 3, enter, 2, enter, -3, enter, -16. And then my last row was a 1, -3, 2, and a 0. So I put my matrix in, quit that screen. Now we want to do RREF. So second, x -1, go to math, scroll down to RREF, grab that, and then go back and grab that matrix. Second, x -1, hit enter because that's the first one that's on there. And then let's see if we get -3, 1, and 3. So those are sort of long by hand because you got so many systems you got to go through. So it looks like I got time for at least one more of these. So this one's using R's, S's, and T's. 8R minus S plus T equals 17. 3R plus 2S minus 3T equals 26. R minus 3S plus 2T equals -15. So that'll be 1, 2, and 3. All right, let's see. Really, any of these could be good to get rid of. Anyone got a special letter they want to get rid of? So let me think. If I was doing this, either the S's or T's would probably be the easiest. So, hell, I'm going to go with the T's this time. So I'm going to eliminate the T's. So right off the bat, I got a positive T and a -3T. I'm going to multiply row 1 by 3 and get rid of the T's. So multiply row 1 by 3 and add to row 2. So take a 3 times row 1, 3 times 8R minus a S plus a T equals 17. 3 times 8 is 24R. 3 times negative 1S is a negative 3S. 3 times T is a positive 3T. 3 times 17 is 51. And then bring in that row 2, which was a 3R plus 2S minus 3T equal 26. So when we add those, we should get rid of these T's. So let's see, 24 and 3 is 27R. Negative 3 and 2 is a negative 1S. The T's canceled. And this will equal, what's that, 77? So row 4 now we have. So to get row 5, remember now I got to use row 3. So what I'm going to do is row 3, the easiest one looks like, row 1. And I'm going to multiply all these by negative 2. That'll make that a negative 2t. When it adds to that, they'll cancel. So I'm going to multiply row 1 by negative 2 and add to row 2. I mean row 3. So multiply row 1, by negative 2 and add to row 3 so we can get rid of the t's again. All right, so negative 2 times 8R minus a S plus a T equals 17. That'll give me negative 16R. Negative 2 times negative 1 is a positive 2S. Negative 2 times T is a negative 2T. Negative 2 times 17 is negative 34. Add that to row 3, which was R minus 3S plus 2T equal negative 15. All right, when I get done with that, that'll be my row 5. All right, y'all, negative 16 and 1 is negative 15R. 2S minus 3 is a negative S. The T's canceled. Negative 34 and negative 15 is a negative 49. All right, so we got row 4 and 5, put them together. All right, so that's our row 4 and row 5. So the easiest thing to be looks like to me to get rid of the S's. So I'm going to eliminate the S's by multiplying row 4 by a negative 1. So multiply row 4 by a negative 1 and add to row 5. All right, so that's just going to change all the signs. I get negative 27R plus a S equals negative 77. Add that to row 5, which is a negative 15R minus a S equals negative 49. All right, so let me see what is a negative 27 plus a negative 15 going to equal. That's going to give me what? Negative 42R. The S's cancel. And then negative 77 plus a negative 49 is a negative 126. All right, so I can finally get the R's by dividing both sides by that negative 42. So negative 126 divided by negative 42. That's what, a 3. So R is 3. So now I know R, I'm going to go back into 4 and 5. solve for S. Once I know both of those, I'm going to go into 1, 2, or 3 and get the T. All right, so I'm going to use this one, 27R minus the S has to equal 77. So I know R is 3. All right, y'all, 27 times 3 is 81 minus S equals 77. So next we would subtract our 81 so that the negative S, let's see, that's going to be what, a negative 4, and then divide by the negative 1 so that S is a positive 4. So I know R was 3, S is 4. I'm going to go into one of these original 3 equations. So I'm just going to pick 8 times R minus my S, which is 4, plus my T is going to equal 17. All right, so let's see what we get here. 8 times 3 is 24, minus 4, plus T equals 17. I would probably combine these like terms. 24 minus 4 gives me 20 plus T equals 17. And then final step, subtract that 20. And T is what? Negative 3. So my answer would be the R first, which was 3, the S, which was 4, and then the T, which was negative 3. So this is the RST. Always put them in alphabetical order, okay? All right, so let me do that one on the calculator. Let me pull my problem back. Do that on the calculator, and then that should be it. So second x negative 1, go to edit. 3 by 4 we got. So my numbers would be 8, negative 1, 1, 17. Then go to the next row, 3, 2, negative 3, 26. And then the final row would be a 1, negative 3, 2, negative 15. Now, quit that screen. Go get RREF. Enter, and then go back and get your matrix again. Second x negative 1, and enter. So when I get enter, we should get 3, 4, negative 3. All right, so that's going to end it on this. So I'm going to stop my share and stop this video.